Hello everyone, today we are going to solve merge intervals. Given a collection of intervals, merge all overlapping intervals. Okay, so let's see the example here. So for example, we have these intervals right, in the array. The first thing we have to do, we have to sort it. We have to sort it based on the start position so that we can have the correct order. Okay. Then we check whether or not they have overlapping. So sort first. Later on, after the sorting, we can make sure that the first one is always start position is always the smallest. So we just put it into our result here. And then we have to check from the next iteration. Okay, we have to check whether or not they have the interval. So how can we make sure they have the interval? As long as the next interval start position is smaller or equal to the previous interval end position. For example, this one, right? Next start position is smaller than previous interval end position, right? So it means they have interval, right? It means they have overlapping, right? And then so we have to update this. We definitely need to update this. So in this case, we just choose the bigger. 3 compared to 6. We just choose which one is bigger. And in this case, it's 6. So we just update to 6. Okay. And next iteration, we just compare. Compare this interval, the end position. Previous end position, whether or not is bigger than the start position of the next one. Or you can say that the next start position is smaller or equal to the previous end position, and it's not, so we just update the result here. We just put it into our result, and then next iteration we just check the lattice interval. Okay, lattice interval end position, whether or not it's bigger than the start position of the next interval. It's not, means they don't have interval, right? You can see the picture. They don't have the interval. So I just put the interval here. And then after we iterate all the intervals, we just return the answer. Okay. And let's see another example. Okay. It's the same, right? After sorting, we just put the first interval to our result. 1, 7, and then we start compare whether or not the next start position is small or equal to the previous interval end position. It is, right? 7 is bigger than 2. It means that they have interval overlapping, right? And then we have to update it. We definitely have to update this. So we just compare whether or not which one is bigger. We just choose a bigger one. Okay? In this case, the previous one is bigger, right? So we don't have to update. So let's leave it there. So this one is completely merged into this interval. And then we compare this, right? Whether or not the start position of this interval, right, is smaller than previous interval end position. Right? In this case, it's not, right? They don't have overlapping. So we just put the answer here, 18. And then again, whether or not the start position of this interval is small or equal to the previous interval end position. In this case, they have at least 5 unit difference. So it means they don't have intervals. So we just put the original interval here. And then after loop through the intervals, we just return the result. Okay. So let's see the code in action. use this as an example. So let me, as a beginning, we just create a result, right? Result 1, and then in the end, just return the result. And we have to check the edge case or boundary condition. If the interval if the input is nil, it's nothing, or the length of the interval it's 0, we just return nothing, right? And then, as I said, because we have to sort the intervals. So let me use sort slice, put the interval here. Function I j int bool. Okay, turn intervals I. Okay, so after sorting, we can make sure that the first interval in this array, okay, the start position is always the smallest. So we just put the first one into our result. Interval 0, and then we start from 1. I start from 1. It means that we will start compare from the second interval. I plus. As I said, okay, we have to check, right? So let me get the interval. We have to check the previous one, right? So previous one already in our result. So is length is minus 1 means we will get a previous interval. Okay. And then we have to compare whether or not our current interval start position of this current interval is smaller or equal to our previous end position. If it is, it means that we have overlap. And if we have overlap, we will do something. If we don't have overlap, this one we just update our append or push to our result. And then in here we have to update the previous interval end position, right? So in here, let me create a helper function. If let me use A and B. Okay. If A bigger than B, just type A. Otherwise, return B. What's the problem here? Okay, yeah, we have to compare for the sorting. We have to compare the start position. So start position is 0. And back to here. If the current start position of the interval is smaller or equal to the previous interval end position, we have to update it. So update the previous. So previous end position equals to max. We have to choose the bigger one, right? Which one is bigger? Max of the previous end position or the current interval's end position. And that's it. And we will able to solve this question. Let's see. Run code. Okay, submit. Okay. And we forgot about the time complexity. For the time complexity, we use sort to sort this interval, right? And we also loop through it. For the sorting part, our time complexity is nlogn. And for this part, we just use just n, right? And because all log n plus n, I think we can omit the smaller one. So it's nlogn. And for the space complexity, because we create a, let me see, we create a result, right? Result to remember the previous interval and also keep updating it. So the space complexity is O(n). Yeah, and that's it. Thank you.